So very sad for me. And this is one of those weird things that OBS does. But anywho, this one should work, and I have the one from my lecture class, so all that's there. Okay, so every class I generally have a few logistics things to update you all on. So a couple reminders. Reminder to sign up for Top Hat. I sent out the link for that. It's the $20 thing. It is an ongoing process to find the best student response system. Previously, I used iClicker. This time I'm trying Top Hat. One of the other instructors I worked alongside, she's using something else that doesn't have a student cost, and she just pays a one-year thing. So I apologize for the cost, but it is valuable. I wouldn't ask you all to spend money on it if I didn't think it helped. So there it is. But we're going to be doing some of those questions today. However, I will not be counting this towards part of the grade. So I'm just using it. I'm going to use it today. I'll probably use it Tuesday. And then this coming Thursday will be the first time it actually counts towards your grade. So that gives us 2 days to kind of test it, to make certain that your stuff is working, my stuff is working, all the things are working. And that way no one's penalized if there's delays in that or complications or things like that. And if there's mass complications, we proceed from there. But today will be the first day that we're trying it out. And I'll keep you all appraised on any things there. So that's that. We're going to do a lab today during the second half of class. It is not going to be a part of your grade because they still have people coming and going and all that jazz with the class. But this lab will be very valuable because it's going to teach you all how to use basic functions in Google Sheets and Excel to analyze data. And that's going to be a really common theme in our labs. You're going to collect data, and then you're going to analyze data. And Google Sheets/Excel are some of the easiest tools to analyzing data. Anyone that does stuff with money, they use Google Sheets and Excel because it's a fantastic resource for analyzing numbers. And money is just a bunch of numbers. So the skills here will hopefully be useful to you in some fashion. If you ever make a budget or stuff like that, it's probably going to be in Google Sheets or Excel. So hopefully some of those skills will be transferable to other things. That's that. Make certain you all do the financial aid activity by the end of the week. If you don't do it by the end of the week, you know there could be delays in financial aid disbursement, all that fun things. As long as you do it, you get all the points. So easy peasy. And I think that's it. Any questions? Any concerns? Again, if you have a question or if there's something you're like, I'm not sure what to do with, I can almost guarantee 10 other people have it. And if we can resolve it now, I get less emails in the future. Okay, great. At any point, if you all have stuff like that, you're like uncertain on something or due dates or whatever, please, please, please ask me. I genuinely mean it makes everyone's life better. I am happy to answer emails, but the less time I can spend doing that, the better. That's why I do these announcements and try to be really clear with communication. But at any time, if you all have questions, do send me an email. If I get enough emails about a question, I send out an announcement and all as well. But I want to make things as clear and straightforward for you all. So last class, we talked about vectors. And a reminder to you all, a vector is just an arrow. That's all it is. A vector is an arrow that points in a direction. So remember we had the whole, I had you all draw, I gave an arrow and I said, all right, have me draw this arrow. And you told me, okay, we have to describe it with an angle because that gives me a precise direction. And then you had to tell me how large the arrow is. And that's going to be a common theme in this class. We then talked about, okay, great, there's arrows. What does this have to do with trigonometry? We're going to have to break these things into X and Y components. So we're going to practice that some more today. Breaking those into X and Y components. You're going to get lots of practice with this because it's going to come up over the next few weeks and then throughout the semester. It's going to come up in your Physics 2 class. It's a bread and butter skill, foundational skill. And to that end, the other thing we did is we showed this is the notation for vectors. So we have some letter that represents something. I'm actually going to change this instead of A. I'm going to make it something that we'll actually see in this class like V for velocity. So you'll see it doesn't really matter what it is. It could be velocity, position, acceleration, force. These are all vectors, but I just wanted to make it a real thing, in which case I do need to put some units. The units for velocity are ms. Great, it's tucked behind the picture, but through the magic of moving things, it no longer is. And this says that my velocity is 8.66 to the right and 5 up. And when we draw those two arrows, 8.66 to the right, then 5 up. The purple arrow is actually the vector that we care about. That's the actual vector that's represented. And these are the components of it. This is how much it is to the right. This is how much it's up. This statement here, 8.66 I hat plus 5 j hat, that doesn't mean I move to the right 8 and then I move up 5. This is telling you how to draw. This vector is this purple one. So we only use those two things to draw the purple one, but the reality is this v vector, just to like give as much clarity as possible, this v vector says I am moving up and to the right. That's what it's, that is what this represents, is that purple arrow up there. And the way we draw that arrow is by drawing something that's 8 to the right and 5 up. Okay, to that end, I want you all to practice it yourself, / in groups. Try to draw these two arrows. And remember, so these are going to give you the x and y components, but at the end of the day, the answer is a single arrow. We're going to draw a couple arrows to get to the final answer, but the final answer is a single arrow. So draw an arrow for A, and then I'm just going to call the second one B just to distinguish them. Try that one as well. So I'll give you all a few moments, work together. Reminder, there is only one right answer here. So that's the benefit of working with someone else. If you have different answers, one of you is wrong or both of you is wrong. Oh, Peter's got a joke.
All right. That joke of the day is, if you always let the low fuel indicator come on before filling up your vehicle, you're gaslighting yourself.
Great. Look forward to those every day. All right. Thanks for in the stream, still working. This is So I checked with the about that. She said that was something that's on her to-do list. Yes. Oh, okay. That way I'll forget. My memory's trash. You don't need to. If you want to, you can.
I'll try and on my cover. I guess Friday.
Oh, great. If you can do an hour, then great. Is that an expectation? But if you can, hey, that'd be great. I assume you have an office. Is yours like you have a space or somewhere?
Yeah, it's shared with other.
Perfect. As long as you have a space. I just want to make sure you had a space. If not, I could help you find a space. I'm very pleased. These are looking great. Yeah, if you have questions, call me on Uber or the J or LA or anything. All right, looking great, everyone. I'll draw the first one real quick. I'll just draw the final answer. So remember, at the end of the day, you are going to draw probably a couple arrows to help get to the final answer, but the final answer will be a single arrow, and that single arrow should look something like this. It is important that your arrow is more up than left. It is important that your arrow is more up than left. If you instead had drawn an arrow that was like this, even though they're both to the left and they're both up, they're different. Those are vastly different directions. If you travel the top one, you're going to go way, at some later time, you're going to be way up here. Whereas if you travel the bottom one at some later time, you're going to be off to the side. It seems like a subtle detail, but it has a big consequence. And so just to remind you all how we draw this, remember the I part is the X direction. Negative is to the left. So we draw an arrow that's -3 to the left. And then we draw the other one after that upwards. And ta-da, we get our arrow. 6, it should be twice as big as 3. Yeah. You can. Yeah, 100%. You can totally think about this in a coordinate system as well, where you're moving 3 to the left and 6 up, and it gets you the same result. Exactly. Yep. The other thing I want to point out here is, remember, addition doesn't matter. So we're effectively adding these vectors together. It's called tip-to-tail method. If you had instead drawn the 6 first and then the 3 next, oh, look, you get the same answer. You get to the same point. The final answer is the purple arrow. The other two things are just to get us there. So we're going to use those components for various things, but the reality is that is the final answer. And to that end, the other one, so that's going to be 7 to the right and then 1.5 down. So we should have an arrow that's really to the right and just barely down. And that's our result. Same thing. You draw an arrow, 7 to the right, and then you draw an arrow that's 1.5 down, and the purple arrow is the one you care about. The purple arrow is B in this case, whereas in this case, the purple arrow is A. And something I want to point out notation-wise here, this orange arrow, we're gonna see this as time goes on. We'll call this BX, because it's the X part of B. It's the left-right part of B. That X is not right next to B, it's a subscript. So this is a common trend in physics. Subscripts, think of them like adjectives in this class. It is the X component of B. It describes it, and I'm going to go ahead and warn you that the subscripts we're going to have some problems in this class where we'll have like B for object 1 initially in the X direction. Like that is something that will happen. And each of those just represents an adjective. So 1 stands for object 1. I will stand for initial, which is the beginning. X stands for the left-right part of it. We get a lot of subscripts because they're adjectives. And if you have multiple objects across multiple times, you have multiple dimensions, that's a future problem. Don't worry about that for now. I'm just foreshadowing it, that you might see several subscripts next to a thing. So anywho, hopefully you can guess that this one then will be BY. And that's going to be a really common notation we're going to use in this class. Any vector, when we break it into components, say instead this was velocity, we'd have the Vx and the Vy. Say this is acceleration, we'd have Ax and Ay. Say this is force, we'd have Fx and Fy, and yada, yada, yada. Okay, further practice. So here's a vector B, just to keep it consistent notation-wise. What is the magnitude of B? So the word magnitude is a word you're going to see in physics. It means how big is this vector? So you all drew vector B in the last picture or in the last slide. So vector B was the one that points down to the right. How big is that arrow? That's what the word magnitude means. How big is it? Think about like earthquakes. The magnitude of an earthquake is how strong it is, kind of how big the arrow is. And then what is the angle of B with respect to the x-axis? The positive x-axis. So try these out. I'm going to put the answers up here. Anytime I ask questions like this, I'm going to put the answer. The answer is not going to give you any magic insight into how to do this problem, but it will let you check if you did it correctly. And again, check with your neighbors as well. If you didn't get the answer, maybe someone around you did, and they can help you, or I can help you. But I'll actually wait a tiny bit to put the answers because I want you all to do a practice of checking if your answer makes sense. I'll talk about that. Yeah. It does. That's a great question. And how come? Yeah. Which way should this arrow point? To the right or to the left? And which way should it point? Up or down? Yep. And so that's your final result should match the things it makes up it. And so that's always when you're trying to decide, your final arrow should point to the right and it should point down. If it's not doing both of those, you do it wrong. Yeah. What's up?
I remember you said we had to come with an app for like CPUs. What would that be?
Yeah, that's the one that you do it on your computer, on your phone, on any digital device. That's the one. Yep. Who goes to magnitude? What was yours? 7.16. You got. Oh, so we got different answers, right? So then the next question is, how do we do it? How did you all get your answer? Cool. All right. So we're just gonna do that. And generally, there's one quick check we can do that helps us check this. We're finding the hypotenuse. Should the hypotenuse be bigger or smaller than the two sides? Bigger. Both your answers are bigger, so unfortunately, this is going to be wrong.
That's the way.
But yeah, I'll show you. I think I'm not sure where the error would come from, but I can check that in a second if we're stumped. All right. The answer to the first one should be 7.16. Now, quick check to this. If you got an answer that is smaller than either of the two sides, that's an immediate indication you did it incorrectly. Because we are finding the hypotenuse of a triangle. Remember, the hypotenuse is the biggest side. So when you're finding the magnitude, that's the biggest side of a triangle. So the number you get should be bigger than either of the two numbers. This is a great check whenever y'all are doing problems. Because remember, everyone makes mistakes. All you can do is get better at checking them and avoiding them. And this is a mistake I make all the time. Maybe accidentally the negative sign was outside the parentheses or something weird. There's lots of ways that you can end up with the wrong answer. And then the angle is going to be, I don't have that one off the top of my head. 5 divided by 7. All right. If you put the answer as positive 12, it's wrong. The answer is negative 12. And again, we can think, does this make sense? Remember, on our picture, we're finding this angle. And it says with respect to the positive x-axis, if you're below the x-axis, it's a negative angle. If you're below the x-axis, it's a negative angle. That's a really common. So either we would say the angle is negative 12.09 degrees, or you would say it's 12.9 degrees below. So either you could say it's negative 12.09 degrees or 12.09 degrees below the axis. Negative means below. If you put the words below, then you don't need to put the negative. Two ways of communicating the same information. All right, so anyway, I'll go around and check with people. If people have questions, comments, again, ask your neighbors. I'm sure someone around you has the right answer. If not, call one of us over.
They should have all three sides so they can use that.
Yeah. Yeah, so you're not gonna actually get
Right.
that's the key here. And exactly. Since we're below, we're gonna call that angles, which is a measure from the x-axis. It's your
And I got this all.
You're going counterclockwise. You're going clockwise. But again, either the answer say positive 12.09. Magnitude will always be positive. That's a great question. So someone had a really good question. Magnitude is always positive. The magnitude is always positive. And the reason for that is because negative and positives generally mean direction, but when we're talking about magnitude, we're only talking about how big the arrow is. And how big something is only is a positive number. We can't tell how big something is and say it's a negative number. Yes, what's the angle? So sometimes the horizontal so that's always pictures are invaluable. All right, so just to kind of write this out in case you all have any questions about how I got here. Remember, y'all, this is the triangle we started with. There was the x and the y component. When we're getting the magnitude, we're doing the magnitude is going to be the hypotenuse. Remember that side? Let's call it. So I'm also going to show you all some notation. These lines represent magnitude. These kind of like absolute value signs. When you see these represent magnitude of B. So if we want to find the magnitude of B, we'd write it this way. And if we have the two sides, it's 7 squared plus negative 1.5 squared. If you plug that into your calculator carefully, you get 7.16. No matter what, the hypotenuse is always bigger because you're squaring numbers, so they all turn to positive, and if you add numbers together, it always becomes a bigger number. So there's that. Now this one, we're solving for this angle here, and so to do so, we got to do SOHCAHTOA. What sides do we have? You can, in fact, at this point, use sine, cosine, or tangent. You have all three sides now. You all found this side. This side is 7.16. So if you really want, you could do sine of theta equals opposite over hypotenuse, and you could find the angle from that. Or you could find the angle from cosine of theta equals adjacent over hypotenuse, or you could find the angle from tangent of theta equals opposite over adjacent. All three of them works. When you are doing this, I know that the y component is negative. We're not going to put the y component in as negative. The reason for this is just a good practice. When you are doing this angle stuff, put everything as positive and then use the picture to find the angle. I'll give you all a counterexample in just a second to show you why that is. So in this case, I'm going to do the one that probably most people thought about, which is tangent. Again, all of them are correct. So I'm going to put that 1.5. That's my opposite side because it's opposite the angle. And then 7 is my adjacent side. And this is where we're going to do that tangent inverse. So the end result is that theta will be tangent inverse of 1.5 over 7. Remember, the opposite of tangent is tangent inverse. It's a button somewhere in your calculator. Make certain you're familiar with where it's at. If you're not sure, ask us. And this is going to spit out that positive 12.07. And this is going to be a really common trend in this class. When we get a final answer, sometimes we have to define the sign of it, positive or negative, based on the picture. That's going to be a common trend. The picture is invaluable. And so we realize, okay, this is not 12.707 up, it's 12.07 down. So either we chuck a negative sign in front of it, or you just put below the x-axis. Either of these is correct statements. In my case, I'm just going to put the negative just to get us used to that. And I know I put 7, and it should be a 9. Let's see. What would this been on? Yeah. Okay. And we'll put our little degree sign. Woohoo. Because there is 2 ways to measure angle. There's degrees and there's radians. You can either write the word degrees, put the degree sign, whatever. It all works. Okay, so let me give a quick counter example to this of like why I told you all that we had to, I'll leave this for a few seconds, why we put them as positive. And you'll see what I mean. So I'm just going to kind of quickly, so I'm going to copy and paste this. If this was instead -7 and positive 1.5, this would be a vector that's to the left and up. Okay? 7 to the left, 1.5 up. There's my beautiful arrow. If I said, what is the angle of this with respect to the positive x-axis? Here's what's going to happen. We're going to do the same thing. This side is 7. This side is 1.5. We would do the tangent inverse of 1.5 over 7, and that's going to spit out 12.09. That is the angle. So, great, that is an angle. If I asked you for the angle with respect to the positive x-axis, I want you all to spend a little bit of time and see if you can figure out what that's going to represent on my picture, what that value is going to be. If I asked you for the angle with respect to the positive x-axis, it's not going to be 12.09. I want you to see if you can figure out what it is. Discuss all those things. All right, so I just made this quick question. Remember I told you all sporadically I'll make new questions on the fly. I wanted to test the top hat thing. If you've already gotten top hat on your thing, fantastic. Let's just try this out. This will be my first time doing it in class. Very exciting. I'm wondering if I need to hide this thing. All right, it says attach screenshot, so I don't know if it's going to take a screenshot after. Huh? So let's see. Can I see what the picture looks like? No. I'm very curious what the picture looks like, if any of you have it. If it actually had the big window block. Yay, it didn't have the window blocking it. That's what I cared about. Okay. I was afraid that the top hat window would get in the way, and then that would be a problem. But it didn't. If you don't have top hat, that's fine. Right now, as long as you have it by next Thursday, get it sooner than later, because today and Tuesday are the last days to kind of check to make certain it works. Thursday, it'll start to be worth points. So you get a couple days to kind of make certain the system is working accurately for you, and we can resolve any technical difficulties. But this is why this is valuable. I get to see if everyone understands what's going on, or if only a small subset of people do.
Yeah, I just
No one's gonna answer. But it's just like so I think which is still like it is still with respect to so if I read either of those answers, I would be able to tell you which way is next. So communicate the same. All right, I'll give you all like 20 more seconds or something. As time goes on, normally this would match the number of people in class. Again, people haven't enrolled and stuff like that, which is fine. But this also kind of gives me a sense of how long it's taking people. So it gives me a lot of useful feedback, which is why I use this software. All right, give you all 5, 4, 3, 2, 1. Again, don't worry if you didn't respond. It doesn't matter today. Great. Okay. And then I can show the responses so you can see what everyone answered. See, I didn't think anyone would pick D. D is also correct. You'll see what I mean. So the correct answers are C and D. So this is when I just click buttons. Yay. You're like, what? Why is there 2 answers? All right. So let's look at this picture. The first question is we should always draw what we're trying to find. We're trying to find this angle. The positive x-axis points that way. So that is, let me draw it maybe in some black lines. So this is if I drew like a coordinate system. This is positive x, this is negative x, this is positive y. So we're measuring the angle with respect to the positive x. This axis looks trash because it's not lined up. There we go. Now it looks a little bit nicer. So that green one is the one we're trying to measure. And this is where you're going to use some geometry in this class. You need to remember that a straight line is 180 degrees. 180. So if I do 180 minus this 12.09, if this angle is 12.09, 180 minus that's going to get me what I want. And that's going to be that 167.91. Now, I told you all that D is also correct. I didn't think anyone would pick this answer, and that's fine. Remember the negative angle instead of measuring, so both this and this give me the same thing. The negative angle is just measuring the other direction. That's what a negative angle means. It means just instead of going counterclockwise, we go clockwise. At the end of the day, the purpose of this angle is so that if you told me this, I could draw which way it's pointing. That's the reason for this angle. It tells me which way it's pointing. Both answers C and D tell me exactly which way this thing's pointing. No matter which option I pick, it tells me where to draw my arrow. To draw it starting at the origin and pointing up to the left at that angle. So this angle down here, I'll use a different color for it. Pink, sure. This one down here is that negative 192.09. This angle up here is the 167.91. And I'm not going to try to be mean and like trick you all with this stuff in the future, but I put this here just to show you that both are valid. And both are accurate ways of representing vectors. So yay, yay. And this is kind of how I'll do top hat questions in this class. There'll be a question, you all answer it, give you an opportunity. If I see a bunch of you are missing it or stuff like that, I might give some hints here and there. But remember, as long as you all answer every single top hat question in my class, you get 100% of the points for that section of the grade. Anything extra that you get right is a tiny bit extra credit. So don't let these things stress you out. They're not high stakes. These are just ways for you to practice and for me then to get feedback from everyone. As you've noticed, when I walk around the class and I interact with you all, at most I can interact with maybe 2 or 3 tables for each question I ask. That is useful, but it's nice to get feedback on everyone. So that's why I love doing this kind of stuff and why it's a part of the class. Great. Okay. And this is more of the same. This is just reminding of things in writing. So this is one of the, again, this is an example of top hat question. We've already done a few of these. Sure. Let's, without me saying anything. So this is actually one of the questions from the problem set. So that's going to be a common, well, no, sometimes common, sometimes not. All right, then I ask another question. Woohoo. There's 5 options here, but we're just going to say that F is not the correct answer. Fingers crossed. Good. Okay. I should have put there was 5 options, but great news. Option E doesn't exist. There is only one right answer to this question. Check with your neighbors. If you answer differently, one of you is wrong or both of you is wrong. Be prepared for that. I'm always going to ask that. Anytime I come around and ask y'all what you think about stuff, no matter whether you're right or wrong, I'm going to ask you why. Yep. Sounds good. That's good. That's a teacher effect. It continues to be a strong effect that when the teacher goes by, things automatically start working. Or you realize a mistake and things like that. It's an interesting phenomenon. All right. Give you all 5 more seconds. 5, 4, 3, 2, 1. All right. Great. Pause the question. And then I look at things. So we have a vector that's, let's just draw it. Let's just be rigorous. We're going to draw a vector that's 15 to the right. And then we're going to draw one that's 12 up. 12 is slightly smaller than 15. So the end result is something that points up into the, left. I don't know if I said right. To the left and then up. So the only vector that points up and to the left is D. So that's the answer. Boop. Great job. Wow, we all got it. That's good. That makes me feel good. I always like it when everyone gets it right because that means either it's really, really easy or I taught it well. I'll always lean towards the latter because it makes me feel good about myself. All right. Okay, so break things into components. This just something I haven't really said. I almost like to think of like the components as almost like the shadows of them. If you think of it like a light from above, the X component is like the shadow. So actually, I want you all to practice this. Here's an arrow. Try to draw the components of it. Try to draw how much it points to the left, right, and try to draw how much it points up, down. Draw the right triangle. That's what I'm asking you to do. And there is 2 correct answers here as far as right triangles you could draw. Both are valid. There's 2 correct right triangles you can draw. You don't have to have the triangle include the angle I wrote there. It's not a necessity. No, that's fine. The one I just asked. Draw the right triangle for this. Draw the 2 arrows. So you got 2. You can either draw the X component down here, or you could draw it up here. Both are fine. Let me make them accurate. And then you can either draw the y component here or draw the y component here. Notice whenever I'm drawing the sides of these triangles, they're arrows. I'm not just drawing lines. I'm drawing arrows. The reason is direction matters. If I drew this bottom arrow and I instead had it pointed like this to the left, that's wrong. And the question is, how do you know which way the arrow points? It's a really simple question when you know the right questions to ask. Which way does this black arrow point, right or left? There you go. That's the way the bottom arrow should point. Does the arrow point up or down? Up. So my green arrow should point up. That's all you got to ask yourself. Which way do these point? Whichever way the black arrow points. Does it point left or right? Does it point up or down? If at any point your components go in the wrong direction, say for example A is pointed to the right and you put A to the x component to the left, it's wrong. And that's gonna mess things up. Everything should match up. At the end of the day, these components tell you how much does it point to the right. Okay, well it needs to point to the right if it's pointing to the right. How much does it point up? I need to be pointing up, not down. All right, so to put kind of some of these pieces together and some of these skills together, this next one's gonna have a couple steps. I have a vector with magnitude of 4 meters per second. Don't worry about the meters per second now. Just worry that it's 4. The size of the arrow is 4. And it points at an angle of 36 degrees below the x-axis. What is the y component of this vector? Draw a picture before you do anything. This is going to be a super common trend in this class. Always draw a picture. Always. If you're not drawing a picture, my goodness, you're making your life so much more difficult. Yes, great question. Below the positive x-axis. That is important for me to clarify because below the negative x-axis is a completely different spot. Yeah, thank you. Yeah, sure.
Very visual.
Yeah. So, I'm going to give you the coordinate system and I'm going to have you do it. So there's y, there's x. Okay, so it's going to be 36 degrees below the x-axis.
Okay, so we're finding x and y. Or
Just the y.
Just y.
Yep,
Okay.
so we're going to start dead center. And then which direction do I need to go to be 36 degrees below the x-axis?
This way.
So you're going to go down. Your angle is going to be measured from here, and it's going to be 36 degrees. So like this.
Okay.
So this angle is going to be 36 degrees. And then which side is 4?
9 to here.
It'll be this
Oh, hypotenuse.
one. Yep. Because so now we've drawn an arrow that's 4 long,
Yeah.
and then we're finding this side.
So opposite. But this is the part I always got. Oh, it's multiplied by 4, right? So it's like 4 times.
And then one last thing, you're going to get an answer. It's going to be positive. But which way is this pointed, up or down?
Okay. Writing down. Okay.
So then the answer will be positive or negative?
Negative.
Yeah. So first step, y'all, if you haven't done this, draw your, you can draw the coordinate system. And then we're 36 degrees, so imagine you got an arrow, and you got to swing it 36 degrees below the x-axis. That's kind of the way of viewing this. You start with the lined up with the positive x-axis, and you need to swing it 36 degrees below it. And that's how you're going to draw your arrow. So we're going to swing it down so that this is 36 degrees. And my arrow, its size is 4. Great, there's an arrow. Now you got to turn it into a triangle. Yeah, so that's like the point. All right, so to show you all the triangle, there is 2 triangles you could have drawn here, and both work. One has an extra step, but it's not a bad thing. So this is the first triangle you could have drawn. This is totally valid. Remember, we are drawing the components of it, the x component and the y component. So we turn it into a right triangle, and actually just to break this into pieces. So we got great, but remember they have to be arrows. So you have to decide, does the x component point left or right? Y'all tell me which way. Right, so that's going to point to the right. Does my y component point up or down? Great, so that's going to point down. That's important. If you don't put those, the final answer is going to have the wrong, you risk the final answer having the wrong sign. You'll see what I mean as we solve through it. So this is valid. You could alternatively have drawn this arrow or this triangle. And this is also valid, though there is one additional step you have to do. If you draw the bottom triangle, we need to find this angle. And this angle, it's not too tricky to find. I'll give you all like 10, 20 seconds. How would I find that angle? It's a very useful skill to practice. So think about it for a second. All right, I'm hearing whispers of the right thing. It's going to be 90 minus 36. The reason is this is a right angle. This is Remembering that a right angle is being able to spot right angles and recognize they're 90 degrees, and recognizing a straight line is 180 degrees. That's a useful skill set that's going to come into play in this class. So again, both of these are valid strategies. 90 minus 36 is going to be 54 degrees. And I'm actually going to do both ways to show you that both are valid. The process will look very slightly different. Well, very slightly different. So we're finding this side. This is the y component. So this is velocity. Meters per second is velocity. That's a thing you're going to learn in this class. So for now, just trust me that it is. In a future class, I'll show it to you. So this is 4 meters per second. So we are finding the y component of velocity. Notice that both arrows are the same size in the same direction. That's all we care about when it comes to vectors is size and direction. So that's why we can use either triangle. It's both valid. So let's do the pink triangle first. SOHCAHTOA. We know the hypotenuse. In this case, it's the opposite side. So we're going to use sine. So sine of theta is opposite over hypotenuse. We know the angle. So sine of 36 equals what we're trying to find, which is the y component of v, over the hypotenuse, which is 4. You rearrange this. You do some algebra, and you get that it's 4 times sine of 36. And I will warn you, so great, you do this, and the answer is 2.35, and if you say that that's the final answer, it's wrong. The math doesn't tell you the direction in this case. We look at our picture. Your picture is always invaluable when it comes to positives and negatives. Which way does this arrow point, up or down? It's negative. The math isn't going to tell you that it's negative. Maybe if you put sine of negative 36, maybe it would kind of kick that out. But my rule of thumb is use the picture to decide these things. So it's down. You're sometimes going to see me write this sign. This stands for therefore. Therefore is a big word that I don't want to write a bunch of times. So this is the shorthand in math for therefore. It's down, therefore, this. It's just a big word I don't want to write, and mathematicians don't want to write it either. So if you see those 3 dots, that's what it means. It means I'm lazy and don't want to write the big word. All right, so it's negative. Great, so there's the answer. The thing's still going, so you can change it. Not that it changes anything. Let's look at the green one. Just to show you all, it's the same thing, but slightly different. So in this case, in the green triangle, I have the angle, but we're no longer solving for the opposite side. We're solving for the adjacent side. If you notice here, the y component is next to the angle. So we're not going to use cosine. We're instead going to use we're not going to use sine. We're going to use cosine. And cosine is going to be adjacent over hypotenuse. Now in this case, my angle is 54 degrees. We're still solving for Vy. The hypotenuse is still 4. And if you do this math, 4 times cosine of 54, you get the exact same answer of 2.35. Remember, math is logical. As long as you're following the right steps, you'll get the same answer. There is, in physics, multiple ways to solve problems. Every now and then that is the case. As long as you are following logical, correct steps, there is actually sometimes multiple paths to get there. It's kind of like going down a mountain. You can take multiple paths. As long as you're going down, you're going to get there and in the right direction. So, same thing down, therefore, all that. So there you go. There's the answer. The purpose of this problem was to practice drawing right triangles and this whole positive and negative business. Remembering that the picture tells you that sign. And if you put the answer as positive 2.35, it's wrong. And it's one of those things that's going to feel really annoying. It's going to feel really annoying how much a positive and negative sign can affect your final answer in this class. But it's the difference between whether your car is in drive or reverse. Like, it's a big deal. Even though it just seems notation-wise like a tiny little thing, if you're driving forwards versus driving backwards, the consequences are vastly different. So whether or not you're traveling east versus west is vastly different. So it matters a lot, even though on paper it's just a tiny little symbol. And it's one of the most common things that gets forgotten, and it results in all the math being bad. But if you're careful and you think through the logic of whether your final answer makes sense, you can catch these things. So we'll practice that skill a lot. It's a really, really valuable skill. It's one thing to solve a problem. It's another thing to look at an answer and say, does that make sense? And that's a skill that we're going to learn throughout this class. Same thing. If whatever field you all go into as a doctor, it's one thing to come up with a diagnosis. you have all the data, you have all the information of all the things that's wrong with a person. And if the diagnosis is they have a broken arm and there's someone that's like, they haven't run into anything, they're young, they don't have osteoporosis, like, okay, broken arm, like you got to rule out things that don't make sense, depending on all these various criteria. So that's an invaluable skill. All right, great. This is more, this is just it in writing. No big deal there. I'll close this question and then mark it right. Boop. Great job, everyone. Again, if you missed it, that's okay. My feelings are never hurt. I never go through and see who got questions right or wrong. There's no value in that. So you never need to worry about, like, oh, is it one person or no one knows. No one cares. Like, don't stress it if you're like one or two person that gets it wrong. The purpose of these, it's better to get it wrong now than on a test. So, okay. Sure. How much time do we have? What do I want to do at this point? I might come back to this one. I want to teach you. I think we've already talked about this, but we got some slides on it now. So let's talk about adding vectors. So to add vectors, I'm going to show you the easy way, which is visually doing it. So drawing some arrows and how to do it. And then I'm going to show you how to do it mathematically. And generally, you're going to kind of do both. The visual is going to help you check your work, though. Visual is very quick, very nice. So to add vectors, we draw them tip to tail. And this is the process. You draw the first vector. You start the next vector at the tip of the first vector. And you keep doing that, however many vectors there are. If there's 7 of them, draw the next one at the end, draw the next one, draw the next one, draw the next one, until you reach some final point. So I'm going to show you all with this one. So here I have 2 vectors. Let's make it interesting and put a third one. All right, so here's how it's going to go. I'll show you one, and then don't worry, I'm going to have you all practice it yourself. We draw R1. As best you can, you draw it as accurately as you can. So that's R1. Then we draw R2, and I didn't give myself space. So that's R1. R2, we start, so tip to tail, tip of the arrow is the tip of it, and the tail is the end of it. We're going to start drawing R2 right where that one ended. And we do our best to draw R2 as accurately as possible. If your arrows are bad, the final result's bad. This one looks a little bit too large. You don't need to be perfect. You just need to be close enough. I'm not going to be mean on a test and give you like answers that are really similar to each other just to see if you had your protractor ready. I don't expect you to bring a protractor or anything silly like that. I expect it to be close enough. All right, great. That's R2. And then we draw R3. So this is adding vectors. This is what I'm doing right now. This is R1 plus R2 plus R3. That's what I'm doing. I'm adding them. All right, great. What's the end result? What is the direction of R1 plus R2 plus R3? We start at the beginning and we draw an arrow to the end. And with no math, we have found the vector R1 plus R2 plus R3. It does all the math kind of behind the scenes. It's great. So once you do the math, that it should match that green arrow. Super, super nice. All right, so we'll practice that. And then we'll do some with numbers. And if we're lucky, I'll be able to do some with subtracting vectors. Subtracting is the same as adding. You just turn the vector 180 degrees. So that's foreshadowing. But subtraction is just adding a negative. And a negative vector is the same vector pointed anti-parallel. Turn it 180, turn it around the other way. And that's the negative vector. Okay. So, try it. So, if I add the following 2 vectors together, what will be the direction of the net vector? I have A, which is down to the right, about a 45-degree angle. I have B, that's up to the right, about a 45-degree angle. Is the final result horizontal to the right, horizontal to the left, straight down, straight up? There is only one right answer here. Yep. You draw one arrow, then you draw the next one. And the cool thing is the order that you do them in. 2 plus 3 is the same as 3 plus 2. So if you draw Z first and then A, you get the same result. All right, give you all like 10 more seconds or so. Ooh, I think you will sign up for Top Hat. Our numbers are growing. Outside. All right, and 5, 4, 3, 2, 1. All right. Oh, and yeah, that was a good. I just heard Peter mention something. I used a phrase here that I took for granted. Net. In this class, net means total. It means sum. The word net means add all the things together. You're going to hear that word a bunch in this class. Net means sum or total. Combine the things together. So you're going to see that word in this class fast. For like the net force, it means take all the force vectors and add them together. If I ask for the net acceleration, same thing. If ever there's a vocab word that I put up here and you're like, what the heck does that mean? Ask me, because it means I've been doing physics for so long that I forget that there's these words that like are jargon in physics. I try to remember what the jargon is, but when you've been doing something for so long, you forget which words are like not part of other people's vocabulary. Like you've heard the word net, and you might think of like fishing. And you might have heard the word net as sum. In physics, the word net does mean sum, total, add. So, anyway, so here's what we're doing. We're drawing A, we're drawing B, and then we draw an arrow connecting them. This problem says, so when it says net vector, it says do A plus B. Now, the cool thing about math, the cool thing about addition is the order doesn't matter. 2 plus 3 is the same as 3 plus 2. So this is the exact same question as B plus A. And to that end, you could have drawn B first and then A, and look, you end up in the same exact spot. Addition is nice that way. So just something to point out, something that's useful. All right. So the answer is going to be the one that points to the right. Bam. Great job. Okay. Because this doesn't take too much time, I'm going to have you all just try this one. Same exact problem. And I'm going to have to write this out. I say same exact problem. Erase all the things. If I, which vector represents A minus B? Okay, so here's my hint to you all. Hint. A minus B is the same as A plus negative B. It's an addition problem. And a negative vector, so I haven't taught, so I'll mention to you all, a negative vector is the same vector, but pointed the exact opposite direction. Negative B is the same arrow, just put the arrow on the other side, and that's negative B. So if you can add vectors, you can add negative vectors. You just have to know the simple trick. And I haven't sent it yet. All right, let's say you want. Okay. All right, so B points down. A points results. Great. The nice thing is because we turn subtraction into addition, it gets C. It doesn't matter. You can do B first and then A, negative B first and then A, or A first and negative B.
So you do it the same way. It's just
All right, give y'all 10 more seconds. In 5, 4, 3, 2, 1. All right. Again, if you don't get your responses in today, it doesn't matter. Moving forward, we're gonna do that countdown. If you haven't answered, either like if you're still thinking, like holler or something, or like say, wait a second, and I'll wait a few more seconds, or I'll count really slow. All right, so we're gonna do just to show you all. I'm gonna do the B first and then the A. So this is negative B. Remember, the order of math, the order of addition doesn't matter. So if I do negative B first and then A, sure, I get the same result. This is A plus negative B, i.e., this is A minus B. They're the same thing. Adding a negative is the same as subtraction. So my hint to you all, my recommendation when it comes to subtracting vectors, turn it into an addition problem. If you're good with adding, then you can use those skills. Something I want to point out to you all here before we get into the math behind the scenes. Which way does B point? Does B point left or right? Left. Which way does A point? Right. It just so happens in this problem, if we broke them into components, so this is secretly what's going on behind the scenes. B points to the left the exact same amount that A points to the right. So what happens if A points to the left 1 and B points to the right 1, negative 1 plus 1 is 0, and your x components cancel. So as we get into the math of what's going on here, if we pretended like the B component here was negative 1, the x component of A would be positive 1, and if you add negative 1 and positive 1, the left-rights cancel. You are secretly adding components. This stuff is doing that for you. It is adding the x and y components, and it just so happens that my x components cancel out here, and my y components are pointed the same way, so you get a big arrow that's down. That's the secret math that's going on behind the scenes. So, So yeah, that's the next thing we're going to do. Great job. Woohoo. Now we got to actually add them numerically. And I think I showed a little bit of this before. I'm not sure. But as I mentioned, this is where pictures are great. Pictures give you a decently accurate depiction of something. Numbers give you precision. The reason we use math is math gives us precise numbers, and you need precise numbers. It's like saying someone's blood pressure is high. Okay, but how high? There's a big, it can make a big difference whether it's off by 5 or 10 or 15. I don't know enough about what a high blood pressure is, so I'm not giving out numbers. But numbers give us precision. There is usefulness to having a general sense of what's going on. That's what a picture does for us. But we have to do math to get the hard number at the end that says exactly how much. And those hard numbers are very, very useful to make specific things. So great, here's a picture of adding vectors. This is just showing what's going on. So we break them each into triangles. We find the x components of each. We find the y components of each. We add the x components together. We add the y components together. And that gives us the x and y components of the final result. The best way to practice this is with actual numbers. But this is what we're going to do. We're going to make them into triangles, break them into x and y. After breaking them into x and y, we can combine the x's, combine the y's. And to get the final thing, it's not shown on here. If we want to ultimately get r, remember the final thing we're going to have to do is Pythagorean's theorem. So after breaking it into its components, finding its x component, its y component, then we recombine it. So this is going to be a really common trend. Take vectors, break them into x and y, combine all the x's, combine all the y's, and then at the end, Pythagorean's theorem to recombine them. That's going to be the process you're going to see a lot in this class. If you're good at it, problems will be easier. If you're not good at it, problems are going to be harder. So it's a skill that you really, really, really want to get solid. And we're going to get a lot of practice with it this semester. Okay, so let's try it. What is a plus b? And this one I've already kind of written in components form for you. You didn't have to do any xy stuff. Or you didn't have to do any trigonometry necessarily. So a is 3i plus 2j. B is negative 5i plus 4j. What is a plus b if this is the case? Same thing, only one right answer. So I have one more problem after this. I'd like to have you try it. We also need time for the lab, so I probably will still try to do it anywhere there because it's the next step of this. We're actually given the arrows and they have to break them into x and y.
Yeah.
It's a problem with two forces and top forces, but two arrows. Find the total arrow and their forces. And this is also nice because I already gave you 2x and y. The next problem, I'm going to instead give you arrows, and you're going to have to find the x and y. So this is kind of like once you get x and y, yes, it is simple. Yeah, and because this would be just one piece of the problem. Then the question would, so I probably wouldn't ask any test, what's a plus b? I would probably ask, what is the magnitude of a plus b? So what step would you do next if you wanted the magnitude? Yeah. So this is one out of like the 3 steps. Yeah. Alright, what's that? Yep. And just have to actually, it seems really easy because this is just one of the steps. This was picking one. The next problem is arrows. And I'm going to say find the next, combine these here, find the next one. And if I said, what's the magnitude? David, you work on that. No, you could draw it from so magnitude is the x and y together. It's literally so you have the final x. How do I get those two? How do you combine x and y? All right, so this part is, if you're like, man, this is simple or stuff like that, great. My challenge to you that find this simple, find the magnitude of a plus b. Find the magnitude of it. So yes, this is just one step. This is just, hey, combine the x and the y. My challenge to you all is find the magnitude of it, because that is something you will very likely have to do in problems as well. So I'll give you all a few more moments for that, then I'll work it out. And then I'll give one problem, and I'll kind of go through it a little quicker than I'd like to, but I need to give time for the lab. The magnitude is 6.32. All right, so I'll give you all 10 more seconds, pick an answer, and then I'm going to close this one out so we can move to the last problem, and then we'll have a break, and then we'll start our lab. All right, in 5, 4, 3, 2, 1. Okay. So, first question is what's a plus b in vector form? So this is where you just add the x components. So, and I saw somebody write it this way, and I think that was nice. I liked it. Where they put them like this. So they put the I and the j, and then they put the I and the j, and you just add the parts together, the i's together, so you get negative 2i hat, and then you get 6j hat. And you cannot combine x and y by just simply adding. So that's why we didn't just say, oh, a plus b is 4. So that's great, fantastic. I and j got to be separate. How do you get this component? So the answer here is the negative 2 plus 6i. How do you get this final answer, the components? Remember, this is the x and this is the y. If we draw this as a triangle, it's always good to remind what the heck we're doing. So this is negative 2 and this is 6. The magnitude is this big arrow, the hypotenuse. How do you find the hypotenuse? Square root of negative 2 squared plus 6 squared. Remember, when you square that negative 2, it turns to a positive. So I put it in there, but generally when you're doing the square root, don't even bother putting the negative sign in there. It actually makes it more likely you'll mess something up. Negative 2 squared, positive 2 squared, they're the exact same thing. And you get 6.32. And life is good. All right. And so this is, again, we're spending time on this because we're going to see it so much. If you're good at it now, fantastic. If you're not good at it now, that's fine. But this entire first week is dedicated to practicing this skill because it comes up so much. Case in point, this next problem, I'm just going to go ahead and work. So I'll give you all some chances to practice it a little bit, but I'm going to move a little bit quicker than I normally would. Normally, a problem like this, I would say, all right, here you go, have fun, try it out, and then we go around and help you. But because I want to move on to the lab and have enough time for that, I'm going to do a little bit more walking through it than I normally would. Normally, I'd give you all a lot of time to work on it, and then I'd show the answer. In this case, I'm going to give a little bit of time here and there. So let's talk about it, and I'll show you what I mean. Great job on the last one, woohoo. All right, so this problem. What is the net force in the following image and in what direction? I haven't told you what the word force means, so don't worry about that. Reword this problem, add these two arrows together. That's what this problem is asking you to do. I got an arrow that's pointed up to the left with 5,000 units. Those units, the unit for that will be newtons eventually, but again, I haven't taught you force. So this arrow is 5,000, and it has an angle of 12 degrees with respect to this axis. And then we have an arrow over here that's 4,000, and it's up to the right with an angle of 15 degrees. We're just going to kind of cover the whole problem. This is in the problem set. Anytime I give these involved problems, they're going to be problems from the problem set. So I got two arrows, and my question is add them together. So if I call this arrow over here A, and I call this arrow over here B, the question is find the magnitude of A plus B. And so A plus B equals question mark. And what is my angle of A plus B? Remember, we care about the direction and the amount. It not only matters which way this thing is getting pulled, it also matters how strongly it's getting pulled. So, my first thing I'm going to give you all to do, turn both of these arrows into right triangles. You don't need to move them around. You're welcome to if you want. You can get a sense of the visualization. I'll show that in a second. But for now, I have two arrows. We need to break them into X and Y to combine them. Draw two right triangles. Focus on one at a time. Pretend like arrow B doesn't exist and turn arrow A into a right triangle. Pretend like arrow A doesn't exist and turn arrow B into a right triangle. Where the two sides of the triangle are the X and Y. So I'll give you all like 30 seconds to try that.
Oh yeah. Because the angles are already on the side, so it's less work. Like I prefer doing it the other way. But those are already. Yeah, I would love to do it that way. Like if the angles are there.
All right. So for triangle A, we're going to draw it, the Y component. It's going to, which way does it point? It points up. And then the X component, we're going to draw a line here. Does that one point left or right? Oh, I heard a couple of different answers. And the key to that, we look at this big arrow. Does this arrow A point to the left or to the right? It points to the left. So our arrow in the X direction should also point to the left. Whichever way A points, its X component should point that way. Whichever way A points, its Y component should point that way. So great, that's arrow. That's the right triangle for A. And then for B, it's the same kind of, it's going to look very similar because its Y component is very similar, but it's a triangle on the other side. So it's a right triangle. And so now the next steps in this process are that you're going to find AX and you're going to find AY. And then you're going to find BX. And you're going to find BY. And then you'll add the X components together. And so again, unfortunately today, I don't quite have time to go through this. What I'm going to do is I'm going to post a slide with this that has it fully worked out. So you can reference that if you get stumped. But for the sake of time, I'm going to hold off on this, on solving it, because I want to make sure we have enough time for the lab today. And then if we finish the lab early, whatever, and you want to stick around and try it, feel free. But the last thing I want to point out to you all, is AX going to be positive or negative? Negative. AX is going to be negative here. That's probably the most common mistake that'll happen. When you find these components, when you do 5,000 times sine of 12% to get the AX, you're not going to get a negative number. You have to know to put a negative sign in front of that. You have to know to put a negative sign. It's because it's to the left. When you're adding, so, I'll write that over here. When you're doing AX plus BX, the reality is it's going to be, AX is going to be negative. When you do AY plus BY, you all tell me. AY, is it up or down? Up. Positive or negative? Fantastic. B, up or down? Up. Positive or negative? There you go. Those are the questions you have to ask yourself when doing these things. Be prepared for that. And then the last step, once you kind of get these, let's just call this CX and let's call it CY. To get A plus B, it's going to be the square root of CX squared plus, you're going to have to find this. So yes, this is an involved process. Like, yes, it has multiple steps. The more you do this, the quicker this gets. Yes, there's a lot of steps you have to do. There is no shortcuts to this. There's no way to go through this and skip a bunch of steps. I wish there was, but the reality is you have to go through these steps. The more you do this, the quicker it gets. Like, so this problem, when you all first do it, is going to take you maybe 10, 15 minutes or something. After you do this enough times, this problem will take you like 3 minutes. The first time you do it, it seems like a bunch of steps, but as you get more confident in this process, it doesn't take as much time. All right, so we're going to take a break. You are welcome to keep trying this one. If you're like, how do I know if I'm getting it right? The right answers in the problem set. So I'll put that up here. But also give your brain a break. There's plenty of time to practice this another time. Don't feel like you need to do it now. We'll give ourselves about 7 minutes. So when the clocks say, 35 sounds reasonable. Yeah, that one says, when that clock says 35, or when the time is actually around 35, we'll start up again and we'll do the lab. I didn't get to that one. No, that's what the fun one is. So they're gonna drop it. They're gonna position. So they're gonna figure. They're gonna see how far it drops. And then from that, there's a high velocity. And then from that, they're going to find the average of that velocity in the cell, the deviation of that velocity in the cell, and then we're going to make a graph of it. Sure, yeah, no, that's perfectly fine. It points basically straight up. Yeah, there's technically a tiny angle with it. And in the one that I send out, they'll have it all worked out to have that angle. But in this case, if you notice, the left and right kind of cancel each other out. So it basically ends up being straight up. In general, it'd be better that the answer had the angle. Yeah, and better would be better with the angle. Yeah. And in fact, I'll just look for that real quick. I solved it last time and I forgot what it was. Yeah. Okay. I think your numbers are flipped. The reason being, so here you're finding the y component. Do these arrows point more up or do they point more left? So we should expect that our y component should actually be bigger than our x components. So something happened when we plugged it in. Oh, no. Okay, yeah, you're fine. You call these x components, these are actually the y components. Looking at this picture, which side is, so which side of them is the basic? Which of these is the up, down, or the left, right? No, cosine and sine is never associated with either one. Cosine is associated with these cases. And sine is associated with the opposite. And depending on where the angle is in your picture, whether that's the x or the y will vary. Yeah, people always fall into the habit, like it's really common to fall into the habit that x is cosine, adjacent is cosine, and whether the adjacent is y or x is cosine. Yep, yep. So these two go to talking, and then one of these. This is so that's AX. Yeah. Yeah. Yeah, that's fine. That's good. Yep. If you're within 1% to 2% of my answer, you're good. Yep. Yep. Let me set up the web courses. Okay, and so every week, and I'm going to mention this to them, but this will be relevant for you for the grading stuff. So every week they have to make new groups. That is just how the system works. So lab groups, allow self-assign, create 33 groups, limit groups to 3 people. It would be really cool if every week I could make a new lab group category and have them self-assign to it. The problem is when they go to self-assign, they'll see, so say I did make a lab group week 2, a lab group week 3, they will see self-assign. They'll see all the groups from week 1, all the groups from week 2, all the groups from week 3 in one giant gross list. Yes. And so I found, I don't know what, the only solution I have is to delete the groups every single week and do it fresh. And so that just means ideally we'll get the lab grading done each week before I reset that. If you find that that's not the case, I can export this. But the goal is for your grading wise, that really should just be like putting in the, oh, we checked off on every single lab group. You just give them the points and it takes you 10 minutes. With the exception of maybe like 3 or 4 groups that you have to look at. Your grading should be less than an hour each week. And if it reaches an hour, that's still more than I expect. 30 minutes is kind of what I expect. Hopefully. Hey.
I know you're probably already going to explain this here a little bit, but should like the lab group be one table?
Yeah. I'll mention this in just, yeah. And it'll be groups of 3. It can honestly be any, so I say groups, it can be literally, I actually don't care if you'll move around for this. It can be whoever you want, but it'll be groups of 3, and I'll mention that in a second. Where's lab 1? Well, that's odd. I'm glad I checked this.
So there's
Oh, no.
No, there's one less. Yeah,
All right. So we'll go ahead and get started. So today is going to be our first lab. It is not going to be a part of your grade, and the reason for that is it's getting used to various things and systems. We will add, drop, and all that jazz. But it is going to show you the sense of the lab. The lab is fairly straightforward as far as you're literally going to be dropping coffee filters and measuring how long they take to hit the ground. The measurements are very simple because the skills that I'm trying to teach you today, I'm not necessarily trying to teach you physics, like yes, a little bit. Today is a foundation on how to analyze the data, specifically with Excel, Google Sheets, and things like that. So the experiment is purposefully like trivial in terms of it, like it's drop a thing and measure how long it takes, because the analysis is where the interesting stuff in the learning will be happening. If I try to do both and try to do a complicated lab and teach you analysis, then it's too much and things get lost and nothing gets accomplished. So to that end, something we're going to do every single week. So to make your TAs, so Peter here is going to do all the grading for these labs, and I have a nice system in place that makes things easy for him and easy for you and all as well. First thing you all need to do is join a group. So I believe if there's like a people tab or something, you are going to self-assign yourself to a group. Now, there is 33 group options, and each can only have up to 3 students. The max group members is 3. 3 is a wonderful number for group. When you have less than 3 people, it's not ideal because if someone's absent. So 1 person's not a group. You can't be in a group of 1. That's not a group. 3 is really nice because it gives enough for everyone to do. When you have groups of 4, it's often that 1 person's not doing anything. So I found 3 to be a wonderful number. You can technically have 2, but generally we're going to try to get 3. There's 99 students in this class. 99 divided by 3 is 33. Hence 33 lab groups. So coordinate with the people around you and pick a group and join it. That's a good question. You might be able to access it through the browser.
Okay, so like go on.
Yeah, you go through the browser and then you hit like the button that says display. So like on the desktop kind of thing, you should just see it there. So join a group. If you have any challenges or questions doing so, this is part of the learning experience. It's not super critical this week, but in future weeks, this is how your grade is assigned. Your grade is assigned to the group, so you want to make certain you're in the right group. So it is very, very important for future weeks this week. If we run into complications, not the worst thing.
Because my Wi-Fi isn't working.
Sure. What's your name?
Jenny.
All right, what group?
15.
If I'm lucky. I'm hoping your name did not go somewhere. Oh, so good. 15?
Yeah.
Great.
All right.
Yeah. And we're going to do this every single week. Every single week you'll join a new lab group, and very likely will be the people that you normally work with. The reason I do it reset every week is sometimes people aren't here. And so then you find a new group or stuff like that. Or it also just is how the grading system works. So every week we're going to go through this process. Generally you'll work with the same people, but in the off chance people are absent, we can adjust for that. And it makes certain I'm only giving credit to people that are actually here. It's a nice system that's worked well for us. Yeah. Yeah, you're welcome to use the desktops in front of you if you'd like as well. In fact, I encourage, like, the desktops in front of you totally work, and it's a nice big screen that lets everyone see what's going on. So they're there for a reason. You don't have to use your own device. You're welcome to. All right, if you're still trying to figure out how to get added to the group, that's fine. Continue working on that, but I'm going to start talking about the lab because then you can assign yourself to the group kind of while we're doing it and things like that. That's something that, but just so we can get everything kind of moving forward. So if you go to the assignment tab or the modules tab, there's so many places you can access it. If you're on the home page, I think you can find it there as well. You just need to find Lab 1. I don't know why this says Lab 2's this date. That's weird. Anyway, Lab 1. Lab 1 is the one you're doing. Obviously, it doesn't show that it's available because the dates are wrong. So let me just quickly fiddle with that. It is available today. It is due today. Don't worry about it, y'all. If you don't get it done today, remember this one doesn't affect your grade. Don't stress it. The reality is the vast majority of people should finish the lab in class. And the way it's going to work is at the end of the lab, you're going to have me, the TA, or the LA check off your work. Once we check off your work, that signifies that the TA gives you full credit for it. Remember, these labs are basically based on if you put the effort, you get all the points. We're not nitpicking. I'm not wanting the TA to spend hours upon hours grading these lab reports every week. So these are largely, if you do the work, you have us check it off at the end of class, you get all the points, easy peasy, grading's easy, gives you peace of mind, all is well in the world. All right, so hopefully you all should be able to open it now. Lab 1, great. You can go ahead and open the lab report. This is going to be the structure for every single week. It's going to click, it's going to send you, say, hey, make a copy of this Google Doc. I recommend just one person in your group making a copy of it, and then you can share that with the other people in your group so you can work on it simultaneously, or you can just do it on one computer. I don't care. It's up to you. You just don't want several documents with different stuff in each one, and that's confusing. So have one person open it, and then have them share that to everyone else. It says make a copy. You make a copy. And the first thing you all can start doing is you can add your group names to it and the UCF IDs. So you can do that, and then after I've waited a little bit for everyone to get there, I will walk through what the lab is going to be, what the process is, and once I feel like I've given enough instructions, I'll cut you loose to actually do it. If someone in your group is bored, they can come up and grab a coffee filter, and then the meter sticks are over in the corner. Here, I'll move them over here because the corner is a high traffic area. You will need a meter stick, and you will need a coffee filter. Pick your favorite.
This one I called it.
Don't start taking any measurements yet because I want to just give the instructions for the lab beforehand. It's to avoid as many common questions as possible. So yeah, our role today is mainly going to be just kind of walking around in general class, making sure things are smooth, and that's generally going to be so for today. The question will be try to make it as straightforward as possible. I've made a guide that they can reference and I'll tell them about. For today's lab, if you have a template file in the open, you can put that on. But, and then, of course,
Oh, yeah.
it's not critical to have 3, I just don't want more. All right. So, hopefully you filled this out. You put your names and UCF IDs. This serves as a kind of check for us. The reason we put names and IDs, you all will submit this lab report and then check. If you say, oh, I was here this day or whatever, we have a backup on that. We can check those things, all that jazz. When we go around and check your all's work, we can make certain that if you put 3 names, there's actually 3 people in your group. Obviously, we don't want to give credit to people that aren't here because it's not fair to them or you. Well, it's not fair to you and everyone else. All right. So, this lab is very straightforward. We are dropping a coffee filter at 10 different heights and measuring the time it takes to fall from when you drop it to when it gets to the ground. You are going to get terrible data. Be prepared. And that's kind of somewhat the purpose of this lab, is to show you that moving forward, we're going to use a software that lets us collect better data, and we're going to continue to use it, but one thing at a time. So just expect to not get good data. Be prepared for that. Don't use it as still try to do a good job and all that. View it as a challenge, not as an excuse. And that'll be one of the questions kind of at the end, is why is your data bad? So here's how these lab reports always work. There's a background, if anything. So it's generally going to be stuff we've covered. Obviously, I haven't covered velocity, distance, time yet. But in general, we'll have covered the content beforehand. Next, you put your lab report and stuff, and then it moves into, generally there's a procedure. So there's the procedure for it. As we move into future labs, we'll actually develop the procedures as a class. Like, I will have a procedure in mind already, but I want you all to get practice in actually developing experiments. That is a skill. How do you actually test things? If someone just tells you what to do, follow a recipe, great, fantastic. But you're not going to really discover. There is a skill in making the recipe. There is a skill in making the procedure. Again, think of being a doctor. There's procedures you follow to take measurements, but there's a skill in coming up with new procedures that help you test new things. And if you're always just following what everyone else has done, you're not pushing the boundaries of knowledge. So it's a skill in coming up with these procedures. Anyway, for now, you got a procedure. Drop it from 10 heights, measure the time. Now, in this lab, remember, the emphasis is learning how to use Google Sheets and Excel. In this document, I have links to those, but I also want to point out that in the web courses, there's links to the exact same guides. These guides will be available for every single lab, and they give pictures and step-by-step on how to do basic things in Google Sheets and Excel. So, for example, and one of the things I'm going to have you do is calculate velocity. Velocity is going to be distance divided by time, and I don't want you to have a calculator out and plugging those numbers again and again and again. That's incredibly inefficient. Google Sheets and Google and Excel, I mentioned both. Pick your preference. I do both because they do the same thing, but the process is very slightly different. So this week I've given you all a template for inputting data. In future semesters, you will start with a blank document and build it yourself. Scaffolding and all that. So in this Google Sheets document, you'll put your time, you'll put your height, and what you can do is you can do math equations in Excel and Google Sheets, and it's awesome. So one of the first things you're going to do is you're going to measure the height. So let's just say your first height was 5. It's not going to be 5 meters. Notice that the units here are meters. You all have a single meter stick. You are not going to measure 5 meters. So actually, let's put a number here that's reasonable. 0.90. That's going to be 90 centimeters. The marks on your meter stick are centimeters, not meters. Your whole stick is 1 meter. So none of your heights here should be bigger than a meter unless you have like a couple meter sticks and you do some things. You're welcome to do that if we have a handful more. You can go above a meter, but that means you're higher than what you can figure that out. Great. Say the time is 2 seconds. Something you can do in Google Sheets and Google Excel is math. You hit an equal sign, and once you hit an equal sign, it knows that you're trying to do some math. Now, in our case, the math we're going to want to do is the height. So I just click that box, and it is then referencing that value. The division sign is going to be this /. Again, this is all written in the document. This is all written out with pictures and everything. You divide it by the time, you hit enter, and it does the math for you. Now, what's really, really cool about this is, say I have a bunch of numbers here. You don't need to type that every single time. So the other thing in Google Sheets and Google Excel, Great, I typed this function. Look, here it is. It's referencing this value, and when you click it, it kind of highlights the ones. Once you've written it one time, there's this little blue dot here. In Excel, it's a black square. You can click this and drag it down, and it automatically applies the function to all the boxes below it and does the same exact thing. And it's smart, and it knows to, so for the example, this is B2 and A2. This one automatically indexes to B3 and A3. It's great. It lets you do a bunch of calculations very quickly, repeated calculations. So you're going to do that. You're going to see that in the lab thing. Down here, I asked for average. So after you do all the velocities, the next thing I'm going to have you all do is equals. Again, this is all in the guide. I'm just showing you now to give you a sense of what you're going to do. You type the word average, you put a parentheses, and when you select all these things, it calculates the average. Don't do the autofill here. It's trying to be smart, but that's not what we want it to do. Standard deviation, you'll hit equals. You'll type ST. Again, this is all in the guide, so if you're like, it's all in writing. And then you highlight all of this, and you close it, and it does it for you, and it's great. And so this is the skills we're practicing today, is learning how to use Excel to do calculations like average, standard deviation, basic math. Also, you're going to insert a graph of height versus time. And again, this is in the guide, but your goal as well today is to insert a scatter plot, not this. And so there's guide on how to do all these things, how to change the chart and all that jazz. Boop. So you'll make a scatter plot and you'll fit things. So anywho, that's the goal today. You will have an hour to kind of go through this, an hour to drop a thing 10 times, measure how long it takes to fall. That should take you like a minute or two. And then learning how to navigate this, use it, all that kind of stuff. People have varying skills with this. Some of you are already going to be very familiar with this, and it's going to go smooth for you. Other of you have never used any of these before, and that's why we're spending the time on this. So, have a good time. We'll go around and help you all. If there's common questions or concerns, we'll go around and I'll show everyone how to do it as a whole. But there you go. It's in the right stuff. So, no, that's fine. This template only exists for class moving forward. There's one outside the room. Otherwise, I don't know. Josh knows.
Yeah, there's one outside.
We just need water.
Yeah.
Are you wrong?
So I don't want to do it and then like.
When you drop your coffee filter, drop the bottom facing down, otherwise it'll flip on you and your numbers will be even worse. Bottom down. Yeah. You'll see. If you drop it the other way, it'll flip on you. It's more stable. At first I thought you were really fun. No. You're good. I was looking around, I was like, there's no way you're doing this in your head.
That's totally okay.
Yeah.
So 5.
He's not running.
Yeah.
start with.
Yeah, so the lab was all your analysis skills, that's it will be in both your analysis.
On the bottom side.
So you do it like this. No, that only, yeah, you, that is what analysis. Wait. Yes, that is a nice organized. And you'll have, yeah, so that way everyone has a consistent, we know where to look for things. Yeah.
We gotta get at this thing.
And just a reminder, all your heights should be less than 1. If any of your heights are bigger than 1, your unit conversions are way off.
Right.
Oh, yeah, but it's also students.
It's good to know your time forward up. That's better for you. That's down. You actually have to see it.
It's just he said her do.
Okay, last one. That's not.
I can't get to it. I'm just gonna hop over.
Start that again. You work this time? Was it the blue dog?
Yeah, but it's not real science, like actually
So that's where sick things come in. This is where so that's fine. Yeah, so it's just it makes it easier for you to do. Yeah. It still does the same thing. No way, you just deleted it. So you're familiar with Excel. You know the buttons. You actually type. That's not terrible. There's at least a trend. Because as time goes, as the height increases, the time shifts. That's good. You're at least seeing that. When I did this experiment last time. No. So that's why I was like, this is better. But I didn't have as organized of a document. Yes, and the way I've set up the document for them does that. I put time on the left and velocity on the right, or position on the right. Moving forward, that's to once y'all get to the graphs, you are going to make a graph of position versus time. I just want to point this out to you all. The template already has it set up, but I just want to point this out for future semesters. Remember, in future ones, you're going to start with a blank document. Time is always pretty much going to go on the x-axis. And for it to be on the x-axis, it needs to be the first column. So the template document has that built for you, but I'm just pointing this out because in future labs, you're going to need to make this. And you need to know that time goes first and then your measurement. Just pointing that out for you all. So that when you make your graph, your things are on the right spot. Okay? In this case, they are in the right spot. It's purposeful, but I wanted to point that out to you. This is just no. Yeah. This is. Yeah, I just want average and standard deviation and making a table. Then just have to apply. Yep, that's perfectly fine because it'll get submitted for the group. And when he assigns a grade, it'll be to the group and everyone. Yep. That's actually really nice. I'm very happy. That's the best that I've seen in my further slide. I'll make it one plus stick. So it's in 7 years. Your stick is 8. Now, what's cool is all you gotta do is move the decimal places. Or just type it. Your first height was 1 here. The second height was 0.9. Yeah. Yes, your velocity would be so good. 1 second. Good. I just recognize that. Yeah, but And whenever you reference the and that's what you really Black Shadow will fit equations to it and it will map those equations to equations we know, and you will need when you all are making your graphs, make certain you not only have the line, but also you have the equations and the R squared. There's a guide, it's in the guide on how to do that. You need all of those because we're going to use them in the future. Oh, you plot in height and velocity? I only want height. Oh, so you plotted an additional column. I only want you to plot these two. So the blue line. Yeah. So you can actually I think collect your red data all in there and hit delete. And remember, don't leave before we come and check your work because we need to help make sure it's all good. Even though normally it would be graded. Normally at the end we check it off so you get the grade. In this case, I want to check it off to make certain you know what you're doing before we get into our next week labs and all that jazz. That's what the checkoffs are for. Did you actually do things correctly, or how do we need to help you?
No, very nice. Yeah. So I'll grab a sheet of paper. So we're checking off here. As they finish, you just write the group over on a sheet, and then we give a sheet. And when they get to their and this one they come over, they sit their desk. Here's the question about it. If one or two of these examples, just kind of ask them that. See what they look for. You don't have to look into all the details, but it's just basically check that and see the data. If they got something to look at, and the question at the end to try to elicit some meaningful thoughts. So then they're saying that word is constant. So then go ahead and add those. Dunzo. Alright. So everything we put together, a lot of your things. Very personal active data was last time. So this is very nice. This is what I wanted it to be last year. And it wasn't. Good. Well, so in your case, it wasn't that a large greater velocity. Remember, you all found a constant velocity. What was it instead? It did result in a greater sum. Looking at our graph here, its height goes up, what's also increasing? So yeah, you'll just fix that, but it's increasing in a linear fashion. Okay. Perfect. Yep. Standard deviation, good. What's your other deviation? Heard the word. Okay. Yeah, good. Okay. The reason I asked that is but good. Yes, that is something. You know, like this will have this associated with it, and it's the same unit. So you're just looking at it. That's good. Now this one's good. Your email might just say higher the height. What did you find? So what's up with that? What? You are correct that gravity should make things go faster. What's up with why doesn't it go faster? What else? No, the air. The air is affected. And you're on stage. Why is the air affecting compound? We're going to learn there's no air, and we're going to get a different result. And so we'll do laugh at that where it's copy goes to a wall. So if you're just normally this would be like for this, we might still do it to see off the table. But this is the process. Yes. So the last step, if you're submitted as a PDF in Web Courses, I just want y'all to go through this so that when it is worth the parts of grade, you're familiar with the process. So there's on the left just hit file, download as PDF, and then only one of you has to submit it, and it'll apply to the whole. Yeah, I'm running that way. Is there a question or just checking out? Alright, I did.
Yeah.
All right, what's up?
We'd be in like 5 o'clock.
So what's this measure of the law? And they do change a little bit. A swooping one, then it would be increasing. Yeah, so good. Yeah. And the reason here is we do faster. So I purposely chose those because they drop inside out. So we really just did a we're like, and all
I have class.
Our professor was like, that stuff like the broad spectrum of that. I didn't really care about like the last you have to write down your notes, which is like yeah, no, you don't have to see it. Or print it, like from an iPad. Copy and paste it.
Alright, all the groups. You all done? We're going to learn the slope of position. So this shows you why is it not possible? Why just? Yeah, so graph makes things clear. What's the only analysis?
I would never.
We're going to learn this class that air is really complicated. But it does things that are sorry, he's on that side, so I'm right on this side. This one is this constant. This is not a straight line to the. What would it look like though?
No, yeah. Bro, you're probably like, you're smarter than me.
Math is like, I
So
feel
we're
like
gonna learn. So in this
No, I
case, we're learning that this is that.
So it's like, this like, how he was saying, like, you're probably gonna forget this stuff in like a month, like that's
What's the
like my
next?
problem.
for 6 years. All middle school and half of high school. So like, for your algebra, I used to do them. So like geometry, didn't do.
But in this case, it's bigger. The future will be long. Without a resistance. Yeah, you're right. One way to show you all. So this one is good. I want the equation for it. So the way to do that.
And you can like machine. We had to go back to some records. I don't think
This line is a constant slope or what is that? That's why we're getting Oh, that's fine. So multiple groups, I haven't taught you all this, but we're going to so in this case, it's showing a constant. Now, so things drop one at a time.
So you just take it separately.
Zero. When
I'm only
drop
asking
this,
them,
it's
I
not
forgot
something
my
that optimized into that big deal. The question is, why would it come down? Before that, while it's grab the shit and what kind of graphs do we expect in the yeah, we can see that. So we're going to go here
And it doesn't help that Ramon is masking.
I'll see you. Alright, that's 6 groups and 2 tables. Is that every one of these 2 tables? Alright, I'll tell Gary that I'll swing over there. Peter, feel free to just do goals questions on this point. Do like, you can get like multiple groups, just like say, what does a graph look like? Yes, practice is downloaded as a PDF and submitting it just so that next week you don't have that. We're not going to grade it, but I just want to make sure you know how to do it. So when it is graded, you'll run into problems. Yeah. They're great at it. Alright, I'm lumping all of you all together. What did the shape of your graph look like? Like, what was the slope when you fit a line to it? What line fit it nicely? Yeah, nice, that thing. Is that a constant velocity or is that a changing velocity? Or did I rephrase that? Is that a constant slope or is that a slope that's changing? It's constant. It's a straight line. It's a nice straight line. I haven't taught you all this. We're going to learn it that position versus time. That slope is the velocity. That is how fast it's going. So that's a constant. However, when I drop something normally, what's its velocity right now? 0. When I let it go, is it still 0? No. So should its velocity be increasing, staying the same, or decreasing? So why was ours the same? What caused that? Okay, it's a curve, which is great. What makes things reach this constant velocity? What's counteracting gravity? And what's causing drag? Air resistance, air friction, air resistance. In this case, why does this have a lot of air resistance? Slow mass, but there's even a bigger quality to it. It's a big surface area. In fact, I crumple this thing up. Now it falls much quicker, even though it's the exact same mass. So anywho, long story short, We're gonna ignore air resistance and a lot of problems in our class. It's very complicated. It's convenient for this lab. But my last question to you all: if we ignored air resistance instead of doing straight line, what would be a graph for the slope is increasing? What would it look like? Yeah, so it's going to do a swoop thing, and in our case, it'll be an x squared. X squared will have that kind of increasing. And so we're going to do some labs with that. What's your all's group numbers? 3, what else? 21, 26, 15. Yeah, you all good? Do submit it as a PDF just so you can go through the motions of submitting as a PDF, so when it's graded, we know that process. So download as a PDF, submit it, just one of you needs to do that.
Are you going to B again? Gabrielle, are you going to B?
Like all my friends on campus, I've never been.
I mean, you don't know like this. Are you going to B or okay, bye. Where'd you park? I parked in B.
So we'll track stuff. Yeah, we'll moving forward. And we'll actually see over time. You'll get more accurate data, but I'm very pleased with what the slide is for now. Yeah.
Are you done with the groups?
We're done. I think so.
Okay, cool. So I have a question about the problems that we were doing like earlier.
Mm-hmm.
So I took pre-calc like years ago.
Yeah.
It was like my freshman year. So I really just like need that kind of like refresher.
Mm-hmm.
So I guess for this problem, like you said, make it into like a right triangle.
Yep. So these two lines here,
Obviously, I have to be straighter.
if they're X, they need to be perfectly.
Straight.
Yep.
Okay.
So.
Kind of like a.
Big old box of sticks.
Yeah. Like I always had a big boxes in my high school as well. I just had to keep the high schoolers from whacking each other with them.
Better.
Good. So that's my X component, and then where's my Y component?
Right here. Well.
Just worry about A for now.
Okay.
So you got how much it points left, right?
Mm-hmm.
Draw me an arrow showing how much it points up, down.
Right.
So we start here. Does it point all the way up to here?
No.
How high?
I get to here.
To the exact height that it goes to.
Okay. So right there.
There you go. And look at that. And what kind of shape is that?
A right triangle.
A right triangle. Yep.
Okay.
So we get the vertical side of it and the horizontal side of it. And then we have our arrows. So why was this one up? Doesn't mean you're wrong. It's like, I don't want you to.
I'm not sure. I guess it's because it's going like that way.
Which way does this one point? Up or down?
It's going up.
So that one needs to point up.
Okay. That one points up.
Why does this one point to the left?
Because it's towards the left.
Which way does this one point?
Towards the left.
There you go.
Okay.
Yep.
Same thing here towards the right.
Yeah, because it's not enough just to draw a right triangle.
Mm-hmm.
On these sides, you have to make these arrows. It's just like you
Okay.
did.
Okay.
but it's important to know how to draw those arrows.
How to